A few weeks ago, multiple different creators posted some videos about a few things that NASA aims, one of which is the
Arc Jet,
which is used to test heat shield materials, and even sometimes fun stuff like this meteorite. The way that the arc jet works is by injecting argon gas into a chamber with a very high voltage current to break the argon into plasma, which is the fourth state of matter. Then the argon is transitioned to plain old air. After the air is turned into plasma, the plasma is then accelerated by a converging-diverging nozzle, making this thing basically a plasma rocket engine. The insane thing is that the plasma reaches a temperature of 30,000 degrees Fahrenheit, and I think most people are smart enough to know that this temperature will melt literally any material, so it may surprise you to know that copper, which melts at a 15th of that temperature, is used to make the arc jet. But to keep the entire thing from melting into a pile of slag, or more accurately, immediately sublimating from a solid to a gas in an instant, NASA flows water through the rings to wick heat away from the chamber. So let's talk about why we are talking about this. As most of you probably know, I'm trying to do a space shot, a rocket that goes over 100 kilometers, and the target altitude I want to hit is somewhere around 200 kilometers. When we come in from that altitude, we'll be coming in pretty hot, and when we hit the atmosphere, we'll hit it pretty hard. So, we will have an insane amount of aerothermal heating, and because of this aerothermal heating, we will need a heat shield at the top of the second stage. And we will probably want one for the first stage with the hot staging ring. Since we are on the topic of heat shields, let's talk about how heat shields work. Talk about the first one. Refractory insulation is less about dealing with the heat as it is managing the heat. In the case of the space shuttle, it used a borosilicate glass-based tile to keep the heat of reentry physically away from the aluminum superstructure. The second one, ablative, is useful if you're coming in at a higher velocity, or you know what? You can just go watch this on Joe's channel. I'll link that video in the description. The reason we needed to talk about this is so that we can design our arc jet to meet the heat expected on reentry of our vehicle. According to some FAA filings, the heat of reentry on the space shuttle reached about 2,700 degrees Fahrenheit, so we can base our reentry profile off of this, although it will be much, much cooler since we are coming in from suborbital, not orbital space.